So in this lecture, I mostly want to talk about modus tollens and reductio ad absurdum. Um, they're really, modus tollens is a valid form of argument. Reductio ad absurdum is actually a type of modus tollens argument, but it's important enough that I think we should talk about it on its own. So that's mostly what I'm going to do this lecture. I will talk about one other valid form using the conditional, but I'm going to focus on this type of argument using a conditional because it's a little bit tricky, especially to see why it's valid. But it's also, especially when we get to reductio arguments, it's a very important kind of argument in philosophy. So that's what we're going to focus on in this lecture. In this lecture, we'll finish up for the most part, valid forms. We'll talk a little bit more about premises in the next argument. So hypothetical syllogism is basically just this idea of building, more statements on one if then, right? So if P then Q, if Q then R, therefore if P then R, right? If P gets you Q and Q gets you R, then, well, P is going to get you R because once you have P, you get Q, and once you have Q, you get R, right? Pretty simple. Basic idea is you put these two conditional statements together. Then you can eliminate the sort of middle one, and you can just say, well, if P, then R, right? Here's an example. If you give the fans things they can throw, they will throw them on the field, right? Well, the first, say one of the first rules of at least baseball promotion, don't give the fans anything they can throw, right? If the fans throw things on the field, the home team will forfeit. If for whatever reason it's unplayable because it's dangerous or whatever, the home team forfeits. So if the fans are throwing, say, baseballs on the field, it's dangerous, the home team will forfeit. So if you give the fans something they can throw, then the home team will forfeit, right? So that's why you don't give the fans anything they can throw. Hypothetical syllogism, pretty easy, pretty basic idea. Is just building conditional statements on top of each other. But I do think it's worth mentioning, right? Okay, so let's talk about modus tollens. And this is a valid form of argument, and it's a pretty important one. If P, then Q, not Q, so not P. Now, some of you might be thinking, well, this seems a lot like, denying the antecedent. That's fallacious. Why isn't this a fallacious form of argument, right? Well, look at what the argument's saying, right? The argument says, well, anytime you have P, you're also going to have Q, right? And if that's true, well, from the fact that you don't have P, that you don't have Q, that you don't have P either, right? If P always gets you Q and you don't have Q, well, you don't have P either. Here's an example of an argument using modus tollens. If the Sasquatch existed, there would be physical evidence, right? Bigfoot, whatever you want to call it. There is no physical evidence that Sasquatch exists. Therefore, it doesn't exist, right? If P, then Q, not Q, so not P. To make it clear why this is a valid form of argument, let's go back and look at a slight variation on what we looked at before, right? If we get a foot of snow, then TCC will cancel classes. Getting that much snow is not the only thing that will cancel classes, but it'll definitely do it, right? Well, if we are still having classes, we didn't get a foot of snow, right? If P, then Q, not Q, so not P, right? I mean, think of it this way, right? Foot of snow isn't the only thing that will cancel classes, but it definitely will cancel classes. So look, if you know from the fact we're having classes, we didn't get that much snow, right? Imagine that you lived in some basement apartment. Maybe you're just too lazy to go to the window. You know that we might or might not get snow. You don't want to go look at the window. You look at the TCC page. If we are still having classes, you know it fell as rain, because if we'd actually gotten the snow, we wouldn't be having classes, right? So, if P, then Q, not Q, so not P. Or think about the other examples, right? If a baseball hits your window, it'll break it. If you were one of these people who lives near a baseball stadium, there's my parents actually live near a minor league park. There's a couple houses near it. The balls go near them all the time. If you see a ball get hit and you wonder, well, did it hit my window? If you come home and your window's still in one piece, you know the ball didn't hit it, right? If a ball hits your window, it'll break. You know from the fact it didn't break, a ball didn't hit it, right? All right. So hopefully that makes sense to you guys why modus tollens works. Even though it might seem at first glance to be similar to fallacious arguments, hopefully you can see why it's not and why it actually works. Now, a reductio argument is an argument that uses modus tollens. And it's a pretty common type of argument in philosophy. You'll see reductio arguments elsewhere, but philosophy uses them a lot, right? You use modus tollens, and what you do is you show that the denial of a claim or a principle or whatever has an absurd result. So we have to accept the claim, right? Or you use it as a way to test a claim. You say, well, you say A, but A leads to B, and B's crazy, so we shouldn't accept A, right? You can use a reductio sometimes to establish a positive claim. A lot of times people use it to try to show that a claim or a principle someone else makes doesn't stand up. Let me give you guys an example. This is, very famous philosopher Immanuel Kant once said it was always wrong to lie, so people threw this reductio argument at him. If it is always wrong to lie, then it would be wrong to lie to a murderer to save his intended victim. Murderer comes to your house, knocks on the door. Imagine the person's hiding in your house for whatever reason. He says, hey, have you seen this guy? I want to kill him. Could you lie to that murderer? Of course you should, right? So since it isn't wrong to lie to a murderer to save his intended victim, it can't be true that it's always wrong to lie. If P, then Q, it's always wrong to lie, then wrong to lie to a murderer to save his victim. Not Q, it is not wrong to lie to a murderer to save his intended victim. Therefore, not P, it is not always wrong to lie. You'll see these a lot. Challenging principles in philosophy, also a lot of times just challenging general moral principles. Here's another example of using a reductio argument, using it to challenge an argument. What this will do, a lot of times you'll use a reductio to challenge a key premise in an argument. You'll show that an argument, that a premise somebody else's argument needs, leads to an absurd conclusion, an unacceptable conclusion, so we have to reject it. So here's the argument we want to challenge. Physician-assisted suicide is wrong. That's because it is always wrong to kill another human being, and physician-assisted suicide involves intentionally killing another human being, right? Physician-assisted suicide, these cases where someone is terminally ill and a doctor helps them die, right? key premise, it is always wrong to kill another human being. Here's the reductio of that key premise. If killing another human being is always wrong, then killing a would-be murderer in self-defense is wrong. Killing a would-be murderer in self-defense is not wrong. So killing another human being is not always wrong. Look, right? We can argue about when it is and isn't self-defense. There's a huge, interesting, and also troubling and important conversation to be had there. But if it's undoubtedly self-defense, right? If someone has an axe and they are running towards you with their axe and they're going to hack you to bits, and you have a gun and you can stop this person from chopping you to bits with their axe, no one would think it would be wrong to kill this person, right? I mean, I guess, every now and then you'll have students who'll try to challenge it, and I'm not sure if they're completely saintly or they're just trying to irritate me, but practically no one would think that killing this person who is going to kill you if you don't is wrong, right? If it were always wrong to kill another human being, then killing Mr. Axe Murderer would be wrong. It's not, right? If P, then Q, not Q, so not P. This reductio is supposed to undermine the key premise in this argument about physician-assisted suicide. And we'll see this a lot, right? In the arguments we talk about in class, there will be a key premise or premises. We'll see if we can come up with a reductio that undermines it. So hopefully you guys see how this works. So how to deal with a reductio argument? Probably the most common way to do this is to reformulate the challenge premise to avoid it. We could do that here, right? We rework our challenge premise to deal with this self-defense case. Always wrong to kill another human being except in self-defense. Then we rework a little bit of the rest of the argument. We can just say, well, physician-assisted suicide isn't killing in self-defense. It is killing. Therefore, it's wrong, right? Look, I'm not... There's more to be said about this argument. There's a lot to be said on the issue of physician-assisted suicide. Very interesting topic. If we were doing an ethics class, I would probably say more about it. We're not doing ethics here, so I'm not going to get more deeply into the topic. I'm not saying physician-assisted suicide is wrong. I'm just trying to rework this argument to deal with the counterexample. Sorry, not counter. Well, it is a counterexample, but, the reductio argument, right? Counterexample is a sort of reductio argument. You present a case that doesn't fit with a principle, and you try to use that to undermine that principle. Philosophers do that a lot. Another way to deal with this is to try to show that the premise doesn't lead to an absurd conclusion. I don't know how you could do that here, but there are other cases where you say, well, it looks like it does, but it actually doesn't. There's a fairly famous case of this in physics. Albert Einstein, his theory of relativity, I don't understand all the math, I don't understand how this works, but I'm getting this from pop science. It seemed like relativity suggested that, current theory at the time was the universe had always existed. It wasn't expanding. It was just sort of staying the same, right? Relativity apparently showed that the universe was expanding. Einstein thought this was a huge problem, so he did all this work to try to show, well, actually, relativity doesn't show that the universe is expanding. We can do a little bit more math, plug things in. We'll show that, relativity fits with the idea of the universe is just staying the same. Try to show, that your premises don't lead to this apparently absurd conclusion. Now here's the problem, though, and here's the reason I bring up Einstein. Because actually it turns out the universe is expanding. We had the Big Bang. The going theory that the universe had always existed, wasn't expanding, doing any of that, was wrong, right? By trying to show that his argument didn't have this absurd conclusion, Einstein actually sort of avoided or missed a huge scientific discovery. So that brings us to the third thing you can do. If you have a reductio argument, you can bite the bullet. So another bit of philosopher's jargon. And what this means is you just accept the apparently absurd or crazy conclusion. Sometimes this is stupid, right? Sometimes you really shouldn't bite the bullet. In the axe murderer case, you shouldn't bite the bullet and say, no, you have to stand there and let yourself be chopped up by the axe murderer, right? But sometimes an apparently absurd conclusion might not be, and you might be better off to bite the bullet here, right? Einstein and the expanding universe, he should have bitten the bullet. Things would have been better. There's some other cases in the history of philosophy. Fairly famous philosopher John Locke, influenced the writing of the Constitution, Declaration of Independence. Locke was a smart guy, right? And Locke was one of the first people, at least in the our sort of tradition, who really argued for religious toleration. But Locke thought a possible objection was, well, if we argue for religious toleration, some people are going to make this crazy claim that we should tolerate atheists as well. And he did all this work to try to show why his arguments didn't commit him to tolerating atheists. And he'd have been better just to bite the bullet and said, yes, we should tolerate atheists. Because now, even those of us who admire Locke, we read the stuff on atheists and we're like, no, why did you have to say this, right? So sometimes biting the bullet might actually be a good thing. Sometimes, as in the axe murderer case, it's just crazy, right? So, also, as in the murderer at the door case, biting the bullet would be crazy. Kant, for all that he is one of the smartest guys who ever lived, bit the bullet on this and tried to say people would have to tell the truth to the axe murderer. It is not Kant's finest moment, right? So sometimes we should bite the bullet, sometimes it's crazy. Deciding which is one of those things that gets us into making judgment calls. Then we're outside of whether the argument's valid or not. Then we're doing something else. Then we're talking about, do we accept the premises or not? That's harder. That's more of an art than a science. That's something we'll talk about a bit in the next lecture.